Alright, second attempt to make a better video with iron filings. Right now, here I have a plastic cube with oil and iron filings floating in it. So I can place it on our head and insert a magnet inside, not like this of course, like this. And we can see the magnetic field lines, right? And now I can take this plastic acrylic base with certain wires. One wire is perpendicular, point straight down into this acrylic surface, a loop, and several loops, a solenoid. So a loop, solenoid, wire. I need to connect it to a power supply. I want to blow the fuse. And now let's start from just a vertical wire right here that goes straight into the screen. I need to sprinkle around iron filings. They don't move yet, and even if I turn on the current, they don't move yet because friction prevents them. So this is what I want to do. And now these filings, when they're in air, magnetic field turns them around and they become a mean to visualize the structure of magnetic field of a straight wire. And it's circular, circles. Maybe not very clear, but well, with these technical options we have, that's the best we can do. Next one is the loop, just a single loop. So I've connected these two electrodes to a power supply. The loop is perpendicular to this screen. Again, iron filings. Again, electric current and some knocking. And now what we see is a structure of magnetic field of a loop. Here and there, magnetic field is similar to magnetic field of a just straight wire, almost circular, then it becomes more and more oval. In the middle, magnetic field line is perpendicular to the loop, right? And finally, several loops connected together, or as we call it, a solenoid. This is a solenoid. So, connection, iron filings, and you can see that inside the solenoid, magnetic field is practically uniform. So this is practically magnetic field of a standard bar magnet, kind of similar to what we saw with iron filings in oil. Yeah, all right. Inside the magnetic field lines all parallel to each other, equally spaced, and outside they bend in loops, in large loops. Well, that's the best we can do. And another student asked, okay, how does right-hand rule work? Well, this is how. our right hand is basically a right reference frame. We just assign a specific value for x-axis, x, y, z. And for the index finger, we assign a letter I, current. And for other three fingers, we assign magnetic field, if they point in y direction. And the thumb is the force acting from magnetic field on this wire. And when we know any two directions, we can figure out the third one. We need to remember, force is always perpendicular to magnetic field and electric current. But electric current might not be perpendicular, might be at a certain angle. But in that case, we always can figure out only perpendicular component and use, again, the right hand. That's it. You can just write on each finger I, B, F, and keep it straight at 90 degrees.